Hi everyone, we are starting with the matrix, a new chapter from mathematics. So it's very interesting chapter. So one day I've started with this chapter. It is easy chapter. Okay, matrix. So I've started with this chapter. So first, this is today we are starting. So we let us start with the introduction part of this chapter. So for exercise 3.1, we have certain introduction part. I'll give that introduction alone. So after completing the introduction, I have planned to give the example problems and we'll go for the exercise and solve all the exercise problems. Okay, today is introduction. Okay, let us see what are the things we have to know before going to exercise 3.1. Okay, so it is new for you. The matrix is new for you. First, you should know the definition for matrix. What is matrix? Okay, so the matrix is an ordered rectangular array of numbers or functions. So whatever I am underlining is very important. I'll explain you. Okay, the numbers or functions are called the elements or entries of matrix. So rectangular array of numbers or functions. That means, see, whenever you write the matrix, you write the matrix function inside this box. This is called as the rectangular array. Inside this rectangular array, you can have the numbers or functions. So what are the numbers? Numbers means you can have the positive numbers like 2, 4, 6, 8, 5, 6, 5, 7. Like that you can have the numbers, or you can have the negative numbers like 1, 5, 2, like that. You can have the root numbers, or you can have the integer, whatever the numbers you can have, complex numbers, whole numbers, real numbers you can have. You can also have the functions like sine theta, cos theta. These are functions. You can also have 1 plus x, 1 minus x. Like this you can also have the functions. See, I'll write and show you. Okay, I'll write and show you. So in the rectangular array you have the functions sine x, cos x, 1 plus x, 6 minus 6, root 6, 0, okay, 2 plus I, okay. Then you can also have 7 by 2 fraction. So you can have fraction, decimal, or any numbers you can have, okay, functions, anything. The next point they are saying is the number of functions are called elements or entries. So this one, it can be a number or it can be a fraction or whatever function. So when you enter something inside, this entering value is called as elements. So 0 is an element, cos x is an element, sin x is an element, 1 plus x is an element, or it can also be called as entries. Okay, they are entries or elements. Clear? That is the given information there. Clear everybody? Okay. Now one more thing is, so you all know that there are three components. There are three, when you talk about the horizontal way, there are three elements, and the vertical way there are three elements. Okay, so when we talk about the vertical element, that is this element, when we talk about, okay, this is called as the row. So your horizontal element is called as row. Okay, sin x, 1 plus x, 6, this is a row. And this vertical element, the sin x, cos x, 0, this vertical element is called as what? Vertical element is called as column. So this is your first row, this is your first row, this is your second row, this is your third row, and this is your first column, this is your second column, and this is your third column. Clear? Okay, so these are the main things you have to remember. Next, moving on to the next, order of matrix. What is order of matrix? See, already we have written that matrix we have written. Okay, so for example, your A matrix is going to be, see, inside the matrix I told the elements are present. How will you represent the elements? So for example, you are going to represent the elements of A matrix as 2, 4, 6, 5, minus 1, 0, 8, 2, root 6. You are going to represent this into the elements means. How do you represent it in the form of elements? First you have to write A11. So this position is A11. That means in first row, first column. A12, first row, second column. A13, first row, third column. A21, A22, A23. A31, A32, A33. So this is how you represent the elements. Always when you represent, so this is a matrix and these are the elements. So for example, here I am having A11, A22, A33 and it is going on. A21, A12, A13. So A22, A23 and it's going on. A31, A32, A33 and it's going on. Here also it's going on. Okay. So here, how will you represent the order of the matrix? The order of the matrix is represented by M by N. M by N. M by N. So this multiplication, this cross symbol, we will tell it as by here. Okay, M by N. So where M is going to be the number of rows, and N is going to be the number of columns. So here, how many number of rows for this A matrix? Tell me what is the order of the matrix. What is the order of the matrix? So for this, the order of the matrix would be, see how many rows you have, how many columns you have. 1, 2, 3 columns and 1, 2, 3 rows. So your number of rows is 3 and number of columns is 3. So this is 3 into 3 matrix. 3 into 3 matrix. So you have to represent the number of rows and number of columns also. So another example also I will give you, just you have to answer. Okay. Another one example. Okay. So sin x, cos x, 1 plus x, 1 minus x, tan x, cosec x. So tell me what is the order of this matrix. So here if you just want to say the order of the matrix, first you have to listen here. See how many rows are there? How many rows are there and how many columns are there? 1, 2 columns are there. How many rows are there? 1, 2, 3 rows are there. Correct? So it is 3 into 2 matrix. So 3 rows and 2 columns are there. So 3 into 2 matrix it is. Clear? Okay. So now moving on to the next. Next we are going to look after the types of matrix. So next we are going to see the types of matrix. Before that, when you just see here, you can able to observe that here you have the capital A and here you have this small a. So the one thing you have to remember here is, I'll write here. Okay, always the name of the matrix is written in the capital letter. Name of matrix will always be in capital letter. Okay, always the name of the matrix will be in capital letter. The element of the matrix will be in small letter. The element of matrix will be in small letter. So the element of matrix will be in small letter, whereas the name of the matrix will be in capital letter. Clear? Right. Now let's move for the types of matrix. So under the types of matrix, first we are going to look after the column matrix. Column matrix is where only one column will be present. Only one column will be present. So if you take the column matrix, only one column, that means how many number of rows you can have? 4 minus 6 root 6. How many number of columns you have? But only one. How many number of rows you have? But only one column you should have. Okay. So these are your examples. Okay. Sin x, 1 plus x, cos x. These are all column matrix. Okay. Then coming to the row matrix. Row matrix is where you have only one row. Only one row. So in the row matrix example you can able to see that 2, 4, okay, 2, 4, minus 6, sin x, tan x, cos x, like this. How many number of columns is not a problem, but only one row should be there. That is called as row matrix. So what a square matrix is? In square matrix, the number of rows should be equal to the number of columns. So in row matrix, the number of rows should be equal to the number of columns. Clear? 1 minute. Okay. So number of rows should be equal to number of columns. That means your m is equal to n. Okay. So example is 2. This is 1 into 1 matrix. If you have then sin x, 1 plus x, cos x, 1 minus x. This is 2 into 2 matrix. Then another one example can be 6, 0, minus 5, 4, 3, root 6, sin x, cos x, 7 by 2. This is your 3 into 3 matrix. This is your 3 into 3 matrix. Clear? 3 into 3 matrix. So these are the examples of square matrix you can have. Okay. Next, coming to diagonal matrix. Diagonal matrix is also a square matrix. Okay, diagonal matrix is also an square matrix. Okay. But some difference is there between square matrix and diagonal matrix. Here also m is equal to n. But where all non-diagonal elements are 0. All non-diagonal elements are 0. That means what are diagonal elements? Diagonal elements means the elements that are there in diagonal elements means the elements that are there in A11, A22, A33. So in this positions, what are the elements are there? Those elements are called as diagonal elements. Other than that diagonal elements, all other elements will be 0. So let us take an example. So your example is going to be A. Okay. Your example is going to be sin x, cos x, tan x. That 3 places only will be filled. Other places and all will be 0. This is 3 into 3 matrix. If it is going to be 2 into 2 matrix, then 2, 4 and other places will be filled with 0. 2 into 2 matrix. Then 1 into 1 matrix means 4. That's it. Okay. So this is 1 into 1 matrix. Okay. This is about diagonal matrix. If it is a scalar matrix is similar to the diagonal matrix. Diagonal matrix where all the non-diagonal elements are 0. Here also non-diagonal elements are 0. But all diagonal elements are same. All diagonal. One difference is all diagonal elements are same. Okay. So all the diagonal elements will be same in scalar matrix. So just take a look of it. So example A. So if it is going to be the minus 5, so all the places you will be having the minus 5 only. Okay. So that is called as the scalar matrix. Okay. So you have the sin x. Here also you will have the sin x only. That is called as the scalar matrix. That is the difference between the scalar matrix and diagonal matrix. Clear? Now coming to the identity matrix. Identity matrix is also the square matrix. Okay, it is also the square matrix where m is equal to n, that condition only. But in diagonal matrix, sorry, identity matrix, what happens is all non-diagonal elements are 0. All non-diagonal elements are 0, but diagonal elements will be 1. Diagonal elements will be 1. Okay, so all the diagonal elements will be 1 only. Okay, that you can see the example here. Just look here. See, A is equal to, you are going to have 1 0 0 0 1 0 0 0 1. So always it will be like this only. The 3 into 3 matrix. If it is going to be 2 into 2 matrix, then 1 0 0 1. This is your 2 into 2 matrix. Okay, and 1. This is 1 into 1 matrix. And it is represented with, okay, it is represented with, you have to be clear here. Okay, it is represented with the letter called I. I stands for identity matrix. Okay. Okay. Next, coming for zero matrix. So when you talk about the zero matrix, what is all about zero matrix here? So in zero matrix, so if you see, means here you have the zero matrix. What is zero matrix? See, zero matrix is nothing but all the elements are 0. That is called as zero matrix. Zero matrix can also be called as null matrix. Zero matrix can also be called as null matrix, and your zero matrix is represented by the letter O. Zero matrix is represented by the letter O. Let us see the example of zero matrix. Okay. So this is an example of zero matrix, 3 into 3 matrix. And this is an example of zero matrix. This is 2 into 2 matrix, and this is 1 into 1 matrix. So this is an example of zero matrix. Clear? So 1 into 1 matrix, 2 into 2 matrix, 3 into 3 matrix. Okay, 1 into 1 matrix. Okay. So now let us move for the equality of matrix. What is equality of matrix? See, inequality of matrix is nothing but, for example, you see you have, let's take, you have you have Aij, and your B matrix you have Bij. That is, Ij is nothing but 1 1 1 2 1 3. That is you have, that is what Aij Bij. Now here you have m into n number of ordered pair. Here also m into n number of ordered pairs. Okay. So what is I am coming to tell here is, when you are talking about the equality of matrix, the order of the matrix should be same. First point is, their order of the matrix should be same. For both the matrix, the order of the matrix should be same. Okay. Next, second one. See, the element of A matrix should be equal to the corresponding element of B matrix. The element of A matrix should be equal to the corresponding element of B matrix. That is nothing but, see, if you just take the Aij, the Aij should be equal to the Bij. So that is nothing but, if you have 2 0 1 0 means your Aij, that is your A matrix, your B matrix should also be 2 1 0 0. Okay, that is what equality of matrix states. Clear? Right. So that's all for today's video. Thank you so much for watching this video and subscribe to BRC Smart Edu channel for more videos. And the next video will be looking after the example sums. Before 3.1 you have 5 example sums. Let us look after that in our next video. Okay, until then, bye.